the topic origin of selectivity in glycosylation reaction with Saccharosamine donor, reported by Bennett. So in that case, first the glycosylation reaction of OTS protected anomeric position and OTVS protected anomeric position. In case of this OTS case, they are getting alpha selectivity, and in case of OTVS, they are getting selectively beta. This varying the this C4 position protected group using armed and disarmed effect. So in case of disarmed, they are getting L beta selectivity, and in case of armed, also getting beta selectivity, but the yield is decreasing. And in case of this acceptor, they change from disarmed to armed, then also they are getting only beta selectivity, but the yield is decreasing when they changing the armed armed to disarmed or disarmed to armed. And the proposed mechanism of in that case, first this hemiacetal react with tosyl chloride, get OTS protected anomeric position, and in this this alpha and beta in equilibrium, this energy is find out using DFT, and attack of acceptor is in various less steps, so they are getting uh, getting selectively because this uh, beta in lower energy compared to alpha, so this reaction is going to in SN2 pathway. And second, when they are using OTVS, so they activate this using BF3, so they get anomeric position BF2 protected, then this convert into 5, and this is very stable, means this is not easily removed. So this another BF3 activate this 5, then got 5 triple dash, then this convert equilibrium with alpha and beta. Same in SN2 pathway, again this acceptor attack on that and give
Hello,
beta
Vivek.
selective compound 8.
Hello.
Hello.
Can you use pointer also? Pointer also you can use.
That is my point. Okay. So they get selectively beta selective compound 8 YSN2 pathway. So checking this mechanism, so this BF3 activate this and this going to beta selectivity. In that case, this is stable. So for activating this BF3, then this activated intermediate is very much unstable. So they are saying the unstable intermediate energy 33 kilocalorie per mole. So they explored this reaction. They used did the activation of hemiacetal using BF3. Then also they got beta selectivity. For that this same starting material in previous case they used here. First they deprotect using HF and got hemiacetal. This hemiacetal is uh, activated by VF3. They got uh, uh, OVF OVF3 intermediate, and this variousless on that variousless intermediate attack of receptors, so get L um, B, alpha selectivity, and same this equilibrium, this alpha part on that this activated by this BF3 and got this intermediate attack by various less step attacked by acceptor and got alpha selectivity. So in case of beta and alpha, this this is more stable compared to this. But the transition state energy also in that case need less compared to this one. But in case of beta pathway, this intermediate is very much stable compared to this one. That's why they are selectively getting this in case of BF3 activation, and this compound also much stable compared to this alpha product. So, so this these two first is to OTS protected to give in conclusion. They activate using OTS and OTVS. In both case, they are getting different selectivity and activation, same activation that used for hemiacetal, and they got selectively beta, and they got alpha linked living group to got beta selectivity, and all this intermediate and product energies find out using the DFT, and all reaction is attack of donor, attack of acceptor into SN2 manner. Thank you.
Nice presentation. Can you go to slide number 5? This one, I think next. So they are getting this 64% as a beta glycoside product.
Huh.
That is because of that stabilization energy is less. That delta E means
Delta E of this 1 minute. Delta E for of this one.
yes.
This minus 61.
No. What is the delta E meaning?
An energy state of this compound.
Generally, how they are
For
calculating like delta E?
for that they are taking some reference now from starting, like they took this for this some to some starting point. So from this they are calculating all these energies, and because like zero. E1 is 0, for reference they are taking 0 something, and
Mm-hmm.
then if this is coming 68, so 61 minus 0 is this delta, because every we cannot calculate randomly, and energy cannot calculate without any reference now. We
Okay.
need some reference to, from there we can start to calculate the energy of
Okay. Basically, delta E is more. That means more stabilization. More, I am telling minus
I
means
think
more.
more activation barrier.
activation barrier.
Maybe.
Where you can repeat.
No. He's telling delta E means the activation barrier.
Mhm. Delta not activation barrier. This is there, like you think compound A
Mm.
randomly. This energy is they are taking. They know the energy of this compound. So in that reference, they are calculating all energy. So this one they are minus, and then they are written here.
Yes, I am thinking that delta E means the stabilization energy. So minus 61 is more stabilized. That's why
This
that is
is
getting the more yield.
stabilization energy only, but
Ah,
delta is representing, because we cannot write E, because we cannot find any energy like in energy form without any reference. That's why they are writing delta E. This is stabilizing energy. It is right.
yes, so they are
I
getting
think
only.
whatever this alpha and beta pathway they have written,
Mm,
delta E transition state,
mm.
that is actually transition state energy. It means that barrier energy only, whatever
Ah,
I'm saying. energy barrier, because they are giving the transition state energy, right, from the reference, means from the starting material. So that much energy is required to cross that barrier, I guess.
This on arrow they are written. This is transition state energy. This
Yes.
curve one, and this energy is for compound stabilization energy. How much compound is stable?
Both are different. So transition state one is that it can be correlated with our energy barrier, and delta E others are like you can tell in terms of stabilization energy.
Huh.
For that purpose, they did the DFT studies.
DFT studied they did.
Okay, and the 64% they got beta. So alpha also they got in the same
Huh.
case.
Because this are pathways, transition state energy is less na compared to this. Only they are concluding here. And this is the this is more stable compared to this, but this this also less stable, this more stable. Some amount we cannot selectively got any if energy difference is very less.
Okay, basically it's not specific glycosylation. They are getting the both alpha and beta. Only they are saying the difference why one is getting less, one is getting more.
By getting more.
Okay, okay, okay.
So to get this beta energy barrier is less in comparison to like beta pathway and alpha pathway. In alpha pathway, transition state energy is less in comparison to beta pathway.
They have shown some graph. It is better to clear there.
I think so, yes.
They didn't give any graph in this paper. No.
Might be they have given in some another paper, because this is the series of paper they have published.
Okay, thanks.
Thank you.
And hello, Vivek.
Yes.
What is here in this slide is barrierless represent?
Means attack of this 7 in that step, they are no need any energy. That's why they are saying various less.
Okay, okay.
Because here this is not this covalent, always not in covalent bond. So this one come here and form this SN2 reaction is going now. So this is very liable to leave it. That's why
Okay.
they are saying various less, barrierless.
And you go to last slide. Back. Again back. Five slide. Go to 5. Here, like you are comparing like this OBF2. You are saying that this is a bad living group, right? Then next slide. What means what you are going to conclude that in this slide?
This slide, what they did, this activation, why this BF3, and this they are getting this BFO2.
So
BF2. So this is uh, means attack is not possible because this is stable. Then
why
this
why they are not here first deprotect OTBS then attack OBF3 like next slide? Like if you go to next slide, he deprotected by HF and then followed by BF3 OAT2.
because here not BF3 BF2 is forming, here BF3 is forming.
No, first he deprotected by HF, right? Then further proceed for BF3 thread.
Because this OH of this attack on this vacant orbital and this is forming. And last slide, they are what they are getting this BF2. In that case, they are not getting any
Like,
BF2.
no, miss. You go to backslide. Like here, if you see the five number compound,
Yes.
say, so they first deprotected by HF, then go for this BFT trade, or he directly go to BFT trade. I'm asking
This
this.
is directly they do na that this BF3 BF3 is using to deprotected this one. This F3 is given this one and O attack on this. That's why this BF2 is forming. They are not
I
going by
think that is the
hemiacetal
promoter
pathway.
system they are using. They are not deprotecting it.
Here
It's the
directly
promoter
they
that is
using for.
indirectly deprotecting and forming intermediate.
Maybe that this 5 double dash OBF2 that is more stable because of this. First, like if
No, because this is not attacking on this. This is not dating bond. In case
hmm,
of this dating bond, okay, because orbital is BF3 is already is there. Like
hmm,
here this BF3 OT2 na
hmm,
working
hmm,
like that. Here is same bond is forming, but in
hmm.
that case this is given or our own electron in the forming the bonding to. Complete the octet of this BF2.
Okay, thank you.
Thank you.
It's visible.
Huh.
You can share how by the you just take a photo and share in your screen.
What they are sharing, Bia?
Turn off the camera.
Like, where is it? Hello.
Where is Adarsha? Adarsha.
I'm here only. I don't have much question, but if someone remember in the very early stages of our presentation, Arif also presented one of the OL paper similar to this only alpha beta selectivity based
This
on
is also
DFT.
oil paper.
No, no, very long before. Maybe I don't know whether this paper or something. That was also OL paper. I don't think so. That is this paper. In the very beginning of our presentation, we presented on paper similar to like this only.
Okay, Vivek, just open the chat section. The Bharat Bhai shared one mechanism for the same.
Chat section from where we find 1 minute.
Go to the Teams.
There.
Go to the chat. Open this picture. Make it big. So
What they
Don't see
are
the
saying.
stereochemistry, Vivek. Just see the like.
Yes, this only I am saying this F is going there and this is not going by hemiacetal pathway. And
Yes, yes.
second one they are using hemiacetal pathway. So here this is using like dative bond is forming. Uh, 1 minute. Yeah, this one is like dative bond like same in BF3 OET is forming now. So in that case same bond is forming. But here this is covalent bond because this is not dative bond like forming.
Yes.
This I am
So
trying to say, but I think I am not able to say. But this is the my pathway to convince him.
So my question is, why they went with the TBS then? Ultimately, they're coming with the hemiacetal pathway only.
So this is first they did with TBS, then they come to check the mechanism with hemiacetal. And
whatever you are talking about that delta E, by any chance that is like a potential energy of any compound, like the compound, or that is the barrier only? I did not get.
1 minute. Yeah.
Can you come to the slide?
Yeah. So this is delta E. 1 minute. I am going this one. This is delta E.
Delta is means what? This
Delta
potential
E
energy of that
for
compound
this
means
compound only. Like
it's like energy compound has that store means.
See, like that, if some reference is there, we are taking A. Okay, this energy they are taking, we are not taking 0 because this compound. Okay, 0 we are taking.
Let's reference, then we can go with the 0.
And this compound energy, because any compound or anything energy we cannot found separately. Like this is coming 4. We need reference.
Oh.
In thermodynamic chapter we read this, we cannot find and also entropy we cannot find in reference.
Yes.
So that like DFT they took any reference, I don't know how they are doing.
Starting with the B, if you go to starting your TBS product 1, starting material, they have taken the delta is 0. No, same slide, slide.
So maybe the energy of this one is 0, or they are taking 0 for this one. Like for whole reaction mechanism, they are took 0 because we cannot take like that. Something like if we are doing different, like they are doing OTVS. If for these two, this TVS or OTS, they are taking same reference point to check the delta E. Maybe.
Okay.
But they are not separately find out like E is equal to 70 minus 75 for this one, because we cannot calculate only E. Always we calculate delta E. For that we need this one. Like same NMR we take TMS now to reference out the things. From here this will come.
Okay, Vivek. Thank you.
Okay, Via. Thank you. How to remove this?